So this is the continuation of a series of videos on Heroku architecture, credential by example. This is part 5, and it is continuation. Last time we talked about some more other core concepts. We're going to switch to a slightly kind of another topic, networking and things, a number of topics related to networking. Specifically, we're going to talk about cache control, compression. There's something called X request ID. I'm going to look at doing custom DNS, and then we're going to look at the Heroku Router. We'll close this up. And we go ahead and open up the project. Okay. CD documents, CD Heroku cert. Okay, so get branch. Okay, I'm going to check out a branch called networking. Check out networking so that I can sort of work on this one separately. Okay, so the first thing we're going to talk about is cache control. By default, neither Express or Heroku itself adds any cache control headers, and it's not uncommon for APIs to not be cached because essentially the APIs are intentionally meant to be sort of dynamic and changing. So one of the things we need to do real quick, it's not so much about Heroku, but just the fact that we need to consider this if we're running APIs, is to add cache control headers. Now, it turns out there's a library called Helmet. So there is a node library, node Helmet. And it has, it's a library for doing all sorts of various HTTP header settings, right? And there's a number of them, but one of which is no cache. So we're going to just for now just use it only for no caching. Okay, but it has other things, but for now we're just going to do it. So to do this, I'm going to first npm. So npm install helmet. Okay, so let's go ahead and go into code. And I'm in server, which is where I want to be. And I'm going to go in here and I'm going to import it. Import helmet from helmet. Okay, so the first problem, it doesn't supply its own typings, and we're doing TypeScript. So let me quickly do correct for that. So npm install types helmet. Okay. And what this will do is install the third-party typings. So then now, maybe I misspelled this. Helmet. Okay, now it's spelled right. I did this before, so I knew that there was no typing for it. And in particular, I don't want to use helmet. I want to actually use the no cache export. And the way I want to use this, I go app use no cache. And this will force my API to not be cached. So let's test this real quick and make sure it's doing what we think. So I will go to no cache. So let me think. I want to go here and I want to type in npm run watch. That should start up my API in sort of this development mode. It's listing on 5000. I go localhost 5000 and open up my developer tools and I go to the network tab and I reload this and I look at this tab. So the key here is in the response headers, once I set that cache, no cache, now it's adding this cache control headers. That actually adds a couple of them. It adds this cache control header, it adds a expires, adds this pragma, and the surrogate control. Basically, anything, any sort of header that's related to no caching, it's added it, right? So essentially now, every time you notice if I refresh, let's see if I go back here and just refresh, let me close this down. If I refresh the API, what you'll see is I'm always getting back a status 200. So previously, actually, in one of the earlier videos, I think we were getting back 304s because the browser was caching it. Now, basically never caches it. So again, that's not so much a Heroku thing, but it's a good practice for when you're doing APIs. Another thing that it's not entirely a bad idea is if you have APIs that return a lot of data, it might be a good idea to compress them with gzip before you send them out to the browser. And Heroku itself doesn't do that, but you can do that yourself in code. So for example, to do that, there's a library called, for Node, there's a library called compression. So let's do that real quick. So if I just do, let's sort of another optimization, install compression. And I happen to remember this one also does not supply its own typings. So I have to do @types compression. And the way you use this library is compression is COM. So it's import compression from compression. And the way you use it is, typo. You just, again, it's just app use compression like this, and that's it. So now by default, there's a bunch of settings on this compression library. So it turns out that in this case, with my simple hello world response, the response is not gzipped. That's because I think the default setting is the compression library doesn't come into play and compress your output until at least it's 1 kilobyte worth of data, right? Because you don't really need to compress these tiny little, tiny responses. So it's just more of a good practice to have in place. Not so much an Heroku thing, but just a good practice. Okay, the next thing is an Heroku thing. So one thing you will notice, let me cancel this for a second. Well, not really. Let me just go here. I'm going to run an out. One of the things, let's see if I can do this by example. So what this is, we're looking at this X request -ID, whatever this is. It's actually an HTTP header that Heroku actually adds. So let me explain the problem, and let's see if we can use this special header to solve that problem. So if I go to Heroku logs, let's look at the output of the logs. Okay, so for example, you can see here, okay, so one of the things that's tricky about this, and I think it's a little confusing. I actually went in and I was troubleshooting this earlier. So let me go up here to where I hadn't actually already done this work. So for example, here is an API request here. Let me blow this up so it's bigger so we can see what's going on. Okay, so I'm gonna go back to where I was looking for this. Now I can barely see what I'm doing. Okay, here we are. So from earlier, we saw that Heroku Router will add log entries into your Heroku log, right? And then you could also have your own code do, here's for example my code logging also. If you notice this carefully though, there's no correlation between this line and this line, right? Meaning I can't tell where, which requests that the Heroku saw correlate with my logging. So there's no way of tie these two together other than they just happen to be next to each other. On a busy server, it becomes really hard to keep track of. So one of the important things that Heroku does is this request ID, which it outputs here on when it does its logging. It actually passes it to your API using this header called x-request-id. So what that lets you do is allows you to then maybe log out to the log that same header in your response, and then I can then filter based on that request ID, and then I can correlate the request from the router back to my logging. So the two are kind of tied together. So let's just do this by example. So the way I would do this, let's see if I can get this right. Let me go into the server, right? And right about in here, I want to grab a copy. I'll call it const request ID equals request dot header, and it's lowercase in the case of Node, so it's x dash request dash ID. Okay, so what this is, save this here. Again. So what I'm doing here is I'm grabbing a copy of the request header, right? And then I'm going to console log it out along with the response here. So let me do this. Do this. I need to make this a variable. Then I'm going to prefix it though, the response with $sign done request D and maybe a colon. So what I'm doing now is instead of just saying outputting the world, right, I'm first outputting, getting a copy of the request ID, prefixing the output with the request ID, then put the output. And then let's see what this does. Okay, so the first step is, let's see what this does locally. I actually haven't tried this. I'm guessing it may not do anything, but I do know that this works on when it's on Heroku itself. So let's see. I have it running locally. So if I go into here and just reload this, right? Right, so you can see right now it's currently undefined. So that basically that header is not being set, which is, you know, a little bit unnerving that it's not working here. But let's see what happens when I push this up to Roku. Make sure I don't have a typo. X request ID. Okay, so what I'm going to do is I'm going to close out of this. I'm going to kill this. Okay. And let me git add all, git commit m networking, and I'm going to push this up to Roku, and then we're going to see if it does what we hope it does. Git push Roku networking, push networking, and then master. Oh, so actually this is, I mean, I didn't intend this to happen, but this is a good example of something that can happen. So in this case, I've been pushing different branches up to Heroku. And what Heroku's observing here is that now I'm basically pushing something that is not a fast forward of the branch that it thought it had, because I had pushed some other branch up in testing. So right now I'm sort of stuck. I can't fast forward that branch to, this networking is not a fast forward of the branch that Heroku has. So one way of fixing this is, there's a couple ways of doing it, but one quick way of doing this is just saying, okay, so I just want to force this. So I can do a git push force Heroku networking. I think it gives some other suggestions too. But right now I'm just going to say, take this commit and just force it up there and use this as the the status of the Roku, repo. Okay? So that's a nice trick, is forcing a push. and this time comes up if you're doing debugging and you're pushing different branches into Heroku, you can get into this situation where you need a force push, get back into the normal flow. Okay, building. So let me close this down. And if I go to Heroku and this and open the app, let's look at the logs here and see what happens. Heroku logs. There we go. So notice now there's the request, right? And there's the request ID 4D63. And you notice instead of just saying world, I've prepended the request ID now so that I can correlate these two. So this is more helpful if I was to use Papertrail, for example. Let's say if I was looking at Papertrail and I saw some log like this that had this string in it. Let's see, I haven't tried this, and I wanted to say, okay, give me everything that's tied to this request. Well, I could just paste that down here and then push search, and you'll see, there you go. I'm seeing now, I'm seeing any log entries that are tied back to that request, including the router, right? So now the router, here's the router, and then here's the one entry for it. So it's a very convenient way of sort of tying together various log entries back to some particular request and not have to kind of piece it together by looking at the logs. So especially when you have a busy log. Okay, so that was about using the request header, x-request ID header, to make your logs more sensible and more easy to read. Okay, the next topic is custom DNS, and I'm going to pause this briefly because I don't think I use. Let me see. Let me double check here real quick. Ooh, I'm already logged in. Good. Okay, that's good. So I don't need to pause the video here. Okay, so right now you notice that my app is running on a URL like Heroku cert, Larkin, Heroku.app.com, right? Now it turns out I actually own a domain called Larkin Tucker LLC, and let's say if I wanted to have this app running on a custom domain instead of this one, right? So we're going to go through the exercise of doing that. So the first step is, what is the first step? The first step is you need to go into this. Okay, so I'm in my local Heroku environment. Let me close down some of these windows. There we go. Okay, so the first step is I want to do a command called of course I didn't write this down, so I think it's called, I'm going to have to research it real quick. Give me 30 seconds. Let me go to Heroku custom domain and custom domains. So this is basically an abbreviated version of this. The first step is, here it is right here. You have to type in Heroku domains add and then the domain. So Heroku domains add, I think it's a colon add. Then you add the domain. So in my case, I have my domains going to be called Heroku cert, and then my domain is Larkin. Now, you can only do this if you have a domain yourself, so you may or may not be able to do this, but I have a domain that I can control the DNS for. LarkinTuckerLLC.com. Okay, if I hit enter, it does something. Now, one of the things it's doing behind the scenes, it's not clear, but it's actually setting up a SSL certificate for that name to be hosted on Heroku. And that way, I can do HTTPS also. But what it does is it tells you what to do. It says you need to create basically a DNS record for this, this unusual looking name here. So what this is like an A record. This is basically where this app runs, but I'm going to create what's called a Cname, which is basically a pointer that says basically Heroku Cert Larkin Tucker LLC is just a alias to this longer domain name. Okay, so I copy that and I go to my, in this case I'm using GoDaddy. So let's see if I can get into my GoDaddy. And it knows who I am. Customer. Okay, I'll visit my account. Okay. I'm in. I click on DNS. Okay. And I hit the plus button, hit add. Type, I'm going to use a Cname. The host is going to be Heroku Cert. Points to, I'm going to paste in that long one. So I misspelled this, cert. Okay, so it's a Cname, Heroku Cert.Larkin.Tucker LLC points to this one that, this A record essentially that Heroku provided. So if I hit save, right, and now this should be available. So I can do, I think the command is, if I type in host, and then I type in this name, let's see what it says. This is a Unix command or a Mac command, and this basically says, tells me description about what Heroku Cert Larkin is. It basically says it's an alias for this more extensive name, which then has these different addresses, right? So looks like it's up and running. So the question here is, so just so you know, this process is of registering your name with Heroku. It doesn't happen instantaneously. So they're basically saying you could also now need to run this command to see if it's done. So I'm going to copy that. I'm going to paste this and see what it says. Okay, so it looks like it's done. So if this works the way I would hope, I should be able to go to, instead of, I can type in this. Well, that's good. So this is the HTTP version. See, it says not secure, but if I think Heroku set up a certificate for me. Maybe I mistyped something here. HTTP. Did I misread type this? HTTPS. Well, that's not good. What's this about? This worked earlier. Okay, I'm going to pause the video for a minute. I'm going to troubleshoot this. I'll let you know what I find out. So you pause the video. I literally just did this with another domain right before this, and of course it worked. So let me pause. I'll let you know what I'm troubleshooting when I'm done. Okay, of course I didn't actually do anything other than hit reload a couple more times, and then it started working. So it looks like it may have been a timing issue. So you notice now that I got a lock here, and it basically connection is secure. It has certificate, cookies, right? And if I click on certificate, I'm guessing, right. Let's Encrypt is the free. This is not going to get any bigger. So it looks like under the hood, Heroku is using Let's Encrypt, and it created a SSL certificate for this Heroku cert.larkintuckerllc.com. So that's one of the things it was doing when I created that, ran that command, the Heroku command to add a domain. Okay, that's pretty much all there is to this. Now, one thing I did not try, let me try one thing, I'm curious. If I go to this and if I say open app, oh, it does use, okay. So it looks like by adding that domain name, before when I clicked on this open app, it would actually go to the URL that, the Heroku URL, and actually no, it still does do that, I'm sorry. This is still the old URL. right, actually, open app. Okay, yeah, this is actually, yeah, it's still valid to use the old URL, but the point here is the new one also does work. So it's HTTPS. It was hello, Heroku. Of course, now why is it not autofilling? That's kind of annoying. cert.orkintuckerllc.com. Yep. Okay. So both work. Okay. That's it for custom DNS. And the last topic, let's see if I can clear this out here. Okay, actually, let me bring up Heroku again. We're just going to talk a little about the Heroku router. And I don't have a great set of visuals for this, to be honest. But it's just kind of walking through what's happening under the hood. So let me go to the resources here. So first of all, right now I'm running only with one web dyno, right? But if I had more than one, right, I'll have a bunch of web dynos running, ready to accept connections. So in front of that, though, when you the way this works is when you go to your URL, before it gets to those dynos, Heroku Router comes into play, and it then routes to one of the many, one or more of your web dynos. And it does it in a way that like a load balancer does. It basically just randomly picks them. So it doesn't do any sort of like smart routing. It just says, okay, I'm just going to randomly pick one of the available dynos to serve up the API. So that's the first thing. It uses HTTP 1.1. That's one thing. Also, the web dyno, the router, can only, for every dyno that's there, it can only hold up to 50 active requests. So for every dyno there, the router can only handle, kind of be prepared to like send to that and maintain open 50 requests to that one dyno. So that's something also to keep in mind. One of the things that the router does, it does some buffering. So the idea here is, let's say your web server, um, your web dyno, gives a response really quick. Instead of having to wait for the client, the web, whatever the client, the mobile phone or whatever is out there, might be really slow. The idea is the router can get the response back, hold up to 1 kilobyte of data, right, and buffer, and then the node server can be off doing its business, and then the router can then serve the client. So that's what the buffer helps with. One thing that's, I don't think it's terribly relevant for like node applications, but when the router gets the request in, it has when it asks for one of the dynos to get the results, there's like a 5-second window where the dyno needs to respond and pick up the request. Otherwise, it basically marks that dyno as having problems. Okay, that's another constraint. The router can handle WebSockets, so that way you can write a WebSocket code in your dynos. It's another thing they can do. And there's one last feature which I don't think is terribly relevant, especially for like Node, RESTful APIs or stateless Node applications. But it does support some concepts. The router, you have to configure it to do it, but it can handle sticky sessions, which essentially means that, so let's say a request comes in and from one of the clients and it hits one of the dynos, right? Maybe you have 10 dynos, hits one of the dynos. And then it makes another request a minute later, right? Sticky sessions allows the router to always route it back, that same client, back to the same dyno. And that's mostly relevant if you maintain some sort of state, like a session state. That stays, let's say you kept it in RAM. Again, that's not terribly relevant for the modern sort of stateless API servers, but some old school servers do require like sessions. Just so you know how it does it, it uses a cookie. So the router actually maintains a cookie. It's called Heroku Session Affinity, and that's the name of the cookie, basically Heroku-session-affinity, and it stores that cookie on the browser, and then when the browser comes in with that cookie, it knows which of the dynos to send the traffic to. So again, it's not something that's probably relevant terribly much today, especially if you're using Node, but something to keep in mind, it does support sticky sessions. Okay, so this was a sort of a potpourri of topics on networking, and so I'm going to stop the video now with that, and then we'll start up some more, maybe more Heroku specific stuff in the next video.